What if I told you that time travel into the future is not only possible, but that you've been doing it your entire life, and that the manual for how it all works was written over a century ago by none other than Albert Einstein? No, we're not talking about flashy DeLoreans or quirky phone booths. We're talking about a real-life time machine, one that's woven into the very fabric of our universe. The reality of time travel is far stranger and way more exciting than anything Hollywood has ever dreamed up. We all know the story. A brilliant, probably a little eccentric scientist builds some fantastic machine, flips a giant switch, and poof, they vanish, only to reappear in the age of dinosaurs or a sleek, chrome-plated future. It's an amazing fantasy, but it comes with a universe of problems. The biggest headache is the paradox. You've heard of the grandfather paradox, right? If you go back in time and, say, accidentally prevent your grandparents from ever meeting, how could you have been born to go back in the first place? It's a logic loop that makes your brain hurt and seems to slam the door on any trips to the past. Then there's the bootstrap paradox, where a piece of information or an object is stuck in a loop, existing only because it was sent back in time with no real origin. These brain benders are great for movies, but they clash with the basic laws of cause and effect. For a long time, that's where the conversation pretty much ended. We were so focused on the paradoxes of the past, we didn't realize the future was already open for business. The key to real time travel didn't come from an inventor's workshop. It came from the mind of Einstein. His theory of relativity completely rewrote the rules of time. Before Einstein, we all figured time was like a giant universal clock, ticking away at the same steady rate for everyone, everywhere. Einstein showed us that was completely wrong. He proved that time is relative. It can stretch and shrink, speed up and slow down. And he gave us two cosmic levers to control it: speed and gravity. This isn't just a theory, it's a measurable fact of our universe called time dilation, and it's the first ingredient for a real time machine. It turns out your movement through space is directly tied to your movement through time. Einstein's special relativity tells us something incredible. The faster you move through space, the slower you move through time compared to someone standing still. The effect is almost non-existent at the speeds we travel every day, but it's there and it's real. Take the astronauts on the International Space Station. They're zipping around the Earth at over 17,000 miles per hour. Because of that incredible speed, they age just a tiny bit slower than the rest of us on the ground. After a 6-month mission, an astronaut comes back to Earth about 0.005 seconds younger than they would have been. They have literally and verifiably traveled 0.005 seconds into our future. It's not much, sure, but it proves the principle. Now, imagine you could build a ship that travels at 99% of the speed of light. The effect would be staggering. For the crew on board, a few years might pass, but when they return to Earth, they could find that decades or even centuries have gone by. By mastering speed, you're basically hitting the fast forward button for the rest of the universe. The second key to time travel is gravity. Einstein's theory of general relativity showed us that massive objects don't just pull on things, they literally bend and warp the fabric of space-time. Picture space-time as a giant trampoline. If you put a bowling ball in the middle, it creates a deep curve. That's what planets, stars, and black holes do. The stronger the gravity, the deeper the curve, and the slower time itself moves. This isn't some far-off idea. It's a puzzle your phone solves every day. For GPS satellites to work, we have to account for the fact that time moves differently for them. Because they're in a weaker gravitational field than we are on the surface, their internal clocks actually run slightly faster than ours. The effect from their weaker gravity is stronger than the effect from their high speed. If scientists didn't correct for this time difference, your GPS would become useless in minutes. For a really dramatic effect, you need something with truly mind-bending gravity, like a black hole. As you get close to the event horizon of a black hole, gravity becomes so intense that time slows to a near standstill compared to the outside universe. Just like in the movie Interstellar, a single hour spent near that cosmic giant could equal many years back on Earth. Gravity is nature's own time machine. So, we have the blueprints for traveling into the future. It's not a matter of if, it's a matter of engineering. But what about the other direction, the one that leads to all those messy paradoxes? Before we dive into that, if this is bending your perception of reality, hit that subscribe button and let us know in the comments. If you had a time machine that could only go forward, how many years would you jump? So, can we ever visit the dinosaurs? According to physics as we know it, the answer is a pretty firm no. While some strange solutions in Einstein's equations do technically allow for paths into the past, things called closed time-like curves, they seem to require exotic stuff we don't think actually exists, like stable wormholes. And even if we found a way, the paradoxes are still a massive roadblock. Some physicists think the universe has its own safety features built in. The Nabokov self-consistency principle, for instance, suggests that the laws of physics would simply make it impossible for you to create a paradox. You could go back, but you wouldn't be able to change a thing that would alter the future you came from. Other ideas from quantum mechanics propose that changing the past would just split off a new parallel timeline, leaving your own history safe and sound. It seems the universe is very protective of its own history. Time travel isn't just for sci-fi. You're a time traveler right now, moving into the future at a steady 1 second per second. Einstein gave us the keys over a century ago, showing us that the universe itself is the ultimate time machine. Through the power of speed and gravity, the laws of physics give us a clear, proven roadmap to the future. The past, however, remains a land of tangled theories and logical traps, likely forbidden by the very rules that hold reality together. We may never get tourists from the future, but we already have everything we need to become pioneers of it. The only question is how fast and how far we're willing to go.